Greetings and welcome. In this video session, we will discuss about determination of metacentric height of floating body by using experimental method.
This is a ship, okay, and this is a water tank. In this we are going to test metacentric height of the ship experimentally. After the manufacturing, metacentric height we obtain. If this metacentric height is coming negative means in that case point number M goes below G. In that case we say that body is not stable. When the metacentric height comes positive, in that case point number M lies above G. In that case we say that ship is stable. So this is done experimentally. Okay. Why? For the validation purpose. Validation means by analytical method metacentric height what we have obtained, this metacentric height we compare with the value obtained by experimental method. And if that value, these two values are coming near, then we say it is validated. Validation means what? Confirmed. So that is why experimental method is used in the ship manufacturing. So in the ship manufacturing, experimental method is used after the manufacturing and analytical method is used before the manufacturing to obtain the metacentric height. Now very first thing that when I will put this ship in the water, then it is remaining in upright position. Then this plumb object, this should match with the vertical line on the protector. It should match. If it is not matching, then these are the two weights. These are for adjustment. By rotating this weight, we can balance the ship. By rotating these weights, we can balance the ship till this thread is matching with 90 degree line. Okay. Just set balance position of the ship without addition of additional weight. Additional weight means these are the weights which we are going to add. We are going to keep. So this is a hanger. Weight of this hanger is a 6 gram, and these are the different weights. Each weight is of 10 gram. So first of all we can take 10 plus 6 means 16 gram. Second reading we can take 26 gram. Third reading we can take 36 gram. This is one approach. And another approach is what? Here, another side, here is a scale. Here for a fixed weight only, means suppose we are taking this 16 gram only. For 16 gram we can keep that weight at 10 mm, 20 mm, 30 mm, 40 mm. Means we can keep the fixed weight at a different location. We are not changing weight. By this we can do the experiment. So there are two approaches. First is either take variable weights or by changing the distance. These two approaches we do. What we will do, we will use left hand side of the ship. We can perform this experiment by applying weight on the left side first. Take the different reading. After that we can take this weight on the right side. Take different reading. Okay. So now I will attach this on the left side. So for attachment, here is a procedure that we follow. This is a hanger weight. Here is a screw arrangement. Now we have added here only one weight, means 16 gram, and we have put that on a 10 mm distance. Now we will put this ship here. For the measurement of angle, now I will have to keep this view before us. Now by addition of this, we are not finding that much inclination. So again we have to add some weight. See now here, this is a 10 mm distance. Okay, for 10 mm distance we are getting, suppose here this angle, if you see here from the vertical line, it is about 3 degree, about 3 degree. Now what I do, I will move this ship by some distance and will keep on the 20 is on the back side of me. Here is a 20, here I have kept for a 20 angle, which I will find, that we will see. Now the angle is increased, say about 6 degree, so second reading is 6 degree, first reading is 3 degree, not 3, we will take 4, increase the distance up now. So we will move this to the 30 mm distance. By 30 mm distance, now we will see the angle. Now angle is again increased 8 degree, angle is 8 degree. Okay, now the last reading we will take at a distance of 40, so we will shift this to the 40. Okay, now for the 40, angle is increased, so this angle is now about 10 degree, angle is 10 degree. So for the different distances, 10 mm, 20 mm, 30 mm and 40 mm, respective angles we got for the respective distances 10, 20, 30, 40, we got the angle 4 degree, 6 degree, 8 degree, 10 degree. This experiment we conducted on the left side of the ship. Application of weight is the left side. Same experiment we repeat by changing this location on a right side. So on a right side again, if we keep the weights at respective distances, we will get one more value, one more column, that is θ2 on a right hand side. So obviously if we are keeping fixed weight and we are maintaining same distances, we will get the same values here in this, means 4, 6, 8, 10. So now what we do, we conducted experiment on a left hand side. For the distance 10 we got 4. Same experiment if we repeat for the distance 10 but on the right side, we will have same angle. Means on the left hand side, right hand side, these two angles will be same, average we have written here. So in this way, for 20, 30, 40, these are the angles we obtain. Now this last column, that is a theta, average angle, that we will use in the calculation of height gm. That is the formula W into X divided by capital W tan theta. W weight of the jockey, that is what, 26 gram. 26 gram means in a kilogram that comes 0.026. Weight of ship, that we have written here, weight of ship 1.316, that is including jockey. And here in the formula X, that is what, respective distance in a meter, theta respective value. So we will have here 4 values of gm, that first of all we will do the calculation, then we will write here. We have got from the result table here, these are the distances for the respective distances in meter. These are the values of theta, average value. For the respective these values, we have calculated metacentric height in a meter. So this metacentric height is in meter, 10 raised to minus 3. Okay, every value multiplied by 10 raised to minus 3. Now this we will take on a y-axis. So here is the scale of y-axis. On the y-axis here we have taken this. This we will take multiplied by 10 raised to minus 1 into 2 into 3 into 4 into 5 into 10 raised to minus in a meter. Angle of heat or theta, this we will take on the x-axis 2, 4, 6, 8, 10. So as per the reading now, first is for the angle of tilt 4. GM value we have got tilt 2.82. 2.82. So near about this point. Here we will get point this. Okay. Second value is for 6 degree angle. For 6 degree angle value GM is 3.759. 3.759 is about this location. 3.79 near to 4. This is the next one. Next value is for 8 degree. 8 degree value is 4.217. 4.2 means near 4. Near 4 at this location. And last reading is for 10 degree angle and the value is 4.48. 4.48 means half. 4 and 5, between 4 and 5, 4.48 here. In this way we got these points. Then we can join the 4 points and we draw this curve. This is called as curve for the metacentric height. Now we will have conclusion. Conclusion is what? First is here as theta increases, means angle of theta increases, value of GM increases, means metacentric height increases. This is first conclusion. Okay, second conclusion here, theta y increase because distance will increase as x value, means distance from the weight, jockey weight increase. That is why GM means metacentric height increases. This is second conclusion. And third conclusion is what? All the values are here positive value. Positive value, that is why here GM is a positive value, hence meta center lies above G. Point G means center of gravity. When this condition happens, means we say that sheet is stable. So in this way, by conducting the experiment, we determine the metacentric height of the floating body, say ship. Here we have seen theory. After that we conducted the experiment at the practical location. After that we did the calculation. In the calculation, result table. From the result table, this is the graph we obtained. Then we wrote the conclusions.
So at the end of this session, you can determine metacentric height of floating body by using experimental method. Subscribe the channel Thermal Engineering for further video sessions. Thank you.